Myself, Dr. Vijay Kwati, Professor, Department of Electronics and Communication Engineering. I'm going to explain the network theory. In VTU module, there will be a 5 modules. The first module is basic concepts. In this modules, we'll study practical sources, source transformations, network reduction using star data transformation, loop and node analysis with linearly dependent and independent sources for DC and AC networks. In the second module, we'll study superposition theorem, Millman's theorem, Thevenin's theorem, Norton's theorem, and maximum power transfer theorem. In the module 3, we'll understand the concepts in transit behavior and initial conditions. In that, you'll study behavior of circuit elements under switching condition and their representation, evaluation of initial and final conditions in RL circuit, RC circuit, and RLC circuits for AC and DC excitations. In the module 4, you'll study the solution of networks, step, ramp, and impulse responses, and also waveform synthesis. In the module 5, you will study two-port network parameters like a Z parameter, Y parameter, H, and transmission parameters, and also relations between these parameters. In this module also, you will study series resonance and parallel resonance. In that series resonance, you have to understand the concept in variation of a current and voltage with frequency, selectivity and bandwidth, Q factor, circuit magnification factor, select with the variable capacitance, selectivity with the variable inductance. In the parallel resonance, we will study selectivity and bandwidth, maximum impedance conditions with CL and F variable, current in anti-resonant circuit, the general case resistance present in both the branches. For this, you have to refer the standard books like one is M.E. Van Valkenburg, Network Analysis. It's a PHI Pearson Education, 3rd edition. And one more standard book is Rai Chaudhary, titled as Networks and Systems, and it is published by New Age Internal Publications. Along with, you can refer the reference books like 8 Kemmerly and Turbin, that is titled as Engineering Circuit Analysis. Another one is J. David Irvine or Mark Nelums. The title is Basic Engineering Circuit Analysis. And the one more is Charles K. Alexander and Matthew N. Sadiku. This is the Fundamentals of Electric Circuits published by Tata McGrail. Along with, you can refer the local authors like Chandrasekhar and Ganesh Rao, Yoga Narasimhan. These are the textbooks, local books are available. These books also you can refer. So I will explain what is the network. What is a network now? Network is nothing but it's a connection of active sources, passive sources. That is, we can call it as a network, and it is not a closed path. That is called as a network. In this network, you have to analyze the circuit and you have to find out what is the current flowing through the each branch of the circuit and also voltage across the each element. For example, for the network, we are applying the input. When you're applying the input like either excitation, we are calling as a excitation. That is, it can give the voltage or current. That has we already know the known or given the data. Once you give this excitation, you should get a output. That we can call as a response. So that means is a network is it's a combination of all resistor, inductor, capacitor, active sources like elements like either voltage source and current source, and it is not formed a closed loop, then it is called as a network. So what is meant by circuit means it contains either passive elements or passive active elements, but it form a closed path. That is we can call it as a circuit. Whatever applying the input, either voltage or current, that we can call as a excitation. When I apply these in voltage or current, we'll get a output. That output we can call as a response. To understand this subject, you need some prerequisites. That is that you already studied in AC single phase circuits in electrical and electronics, or in electric circuits in the first semester, and elementary calculus, that is comes in mathematics, differential equations, that is also comes in mathematics, Laplace transform, that is also comes in mathematics, and also solutions of simultaneous equations by Cramer's rule, and simple matrix operations with real numbers. So these are the diagram for the network and circuit. I already explained what is a network and what is a circuit. Circuit is a combination of all the passive or active elements, okay, and it form a closed path that we can call the circuit. Network means it contains all the above elements only, but it is not a form a closed path. Then it is called as a network. What is meant by electrical network? Electrical network is nothing but it's a combination of a various elements like a resistor, inductor, capacitor, voltage source, and a current source connected in any manner that we can call as a electrical network. So in circuit analysis, it is necessary to reduce the electrical network in a simple form by using some simplification techniques like a mesh analysis, loop analysis, source transformation, and also source shifting, and also by using a Kirchhoff law, that is current law and voltage law, and also star data transformations, we can reduce the network. We can classify the circuit elements in two different categories. One is called as a passive elements, other one is called as a active elements. Then what is meant by passive element and what is meant by active element? What is a passive element? The element which receives the energy or absorbs the energy, and then either it will be converts into heat or stored, and it in an electric or in a magnetic field, it is called a passive element. So transformer is a not an active element because it will not amplify the power level, and power will be remain same in both in a primary and secondary windings. Therefore, transformer is example of a passive element. What is meant by active element? These elements will supply the energy to the circuit, and therefore these elements we can call as a active element. And this example for active elements, it will be include voltage source, current source, generators, and electronic devices. This will require the power supplies. For example, transistor is an active circuit element. It will be amplify the signals. The basic concepts in the network means you have to study the terminology. That means what is the node, okay, what are junction, what is the loop, what is the mesh, what is the practical current source, what is the practical voltage source, what is the reference node, okay, what are the independent voltage source, what is the dependent voltage sources, that you have to study. That are the basic fundamental concepts in the network theory. So what is meant by node or junction? What is meant by node or junction? So node or junction is nothing but a interconnection of a two or more branches meeting at a point that we can call as a node, or we can call it as a junction. You can observe in the diagram where it is the dot is there, no? that we can call as a node. Wherever the dots, no, that we can call as a node. What is a reference node? Reference node is it's called as a datum node. That is, or we can call it as a ground potential. That is zero potential. That we can call as a reference node. That below that you can see that here all the elements will be connected to one point. That is a ground point. That we can call as a reference node, or we can call it as a datum node. So in the center of the circuit, there will be a one current source that we can call as a practical current source, that we can represent it like in the circle only. The current symbol you have to write on arrow mark inside the circle, that we can call as a practical current source. Similarly, in the left hand side, there will be a circle. Inside it is mentioned as a E, or we can denote it as a V or E. Both we can use any notation. And for the here we are using a DC voltage source, therefore you are mentioned as a plus minus, and this symbol is called as a practical voltage source. Another two sources are there. One voltage controlled current source. You can observe in the diagram, above diagram, there will be a current source, and this current will be controlled by the voltage. Therefore, it is called as a voltage controlled current source. These are the dependent sources because it will be dependent on this some other element in the circuit. That means this current source will depends upon the voltage across the L1. So what in the diagram, what is the voltage across the L1? That is V1. Therefore, this current source, okay, will be depend upon the voltage across the inductor L1. Therefore, it is called as a dependent current source. There will be four types of dependent sources. One is called as a voltage controlled voltage source, voltage controlled current source, current controlled current source, current controlled voltage source. But in this diagram, there will be as shown the two dependent voltage sources. One is called as a voltage controlled current sources. That is this, it can be controlled the current by voltage source. Where is the voltage source? That is voltage across the L1. Therefore, that means why it is called as a dependent current source means that this current will be depends upon the voltage across the L1, that is V1. Therefore, it is called as a dependent current source. Similarly, you can observe in the right side, there will be a one source that is also dependent voltage source, that is can called as a current controlled voltage source. That means this voltage source can be controlled by the current. Therefore, it is called as a current controlled voltage source. And observe the diagram. That is, there will be in the symbol is a amber symbol, but for the current, you have to use the arrow mark like this in the above diagram. And in the voltage source, you have to represent minus and plus. And this is a current controlled voltage source. Here, this voltage source can be current by the current, that is I1. So where is the I1 here? That is the current flowing through the R2 resistor. So this voltage source will be depends upon the current flowing through the resistor R2. Therefore, this is called as a current controlled voltage source. Then what is meant by loop and mesh? We can in the diagram observe, I shown this as the loop. It is in a clockwise direction. Inside another loop is there that we can call as a mesh. So what is meant by loop is a set of branches forming a closed path which passes through no node more than once. It is called as a loop. What is a loop means? A set of branches forming a closed path which passes through the no node more than once. It is called as a loop. What is meant by mesh? This makes a loop which does not contain any other loop or loops within. It is called as a mesh. This is the basic concepts of the network analysis, or we can call it the network theory.